from homeworks or whatevers? We've done section 3.4 and 3.5 was what we were checking last time. I had started 3.6, but we hadn't gotten very far and or finished. Mia. 39 from 3.5. Do you have an approximate page number there for 39?
Yes,
215. Thanks. Okay, this was a good one, Mia. So we have that, this is from the implicit differentiation section, just for everybody else's reference. It says if xy plus e to the y is equal to e, find the value of y double prime at the point where x is equal to 0. So this is asking me to evaluate the second derivative with respect to x when x is equal to 0. So what I'm going to start by doing is I want to figure out the y coordinate with this because this is an implicit differentiation problem. Odds are, and Mr. Kulik can tell by looking at it, that I'm going to have a y in both the first derivative and the second derivative that I'm going to have to plug in a value for. So I'm going to figure out what that value for y is straight from the get-go. So all I'm going to do is I'm just going to take 0 and plug that in for x into the original equation. So I get that y is equal to 1 when x is 0. So we have the point like 0, 1. That's what we're going to be evaluating with. So far, so good? Okay. So let's go ahead and take the derivative of both sides. So I'm going to use the prime notation for my derivative. Since they're using primes in the problem, it's fine to use like ddx's or whatever, but the right-hand side is easy. The derivative of e is just 0. To take the derivative of xy, though, I have to use the product rule because that's the product of two variables. So I have x times the derivative of y. Maybe we'll write it this way. And then y times the derivative of x. And then we're going to have the derivative of e to the y. So when I take the derivative of y, I get 1 times dy dx plus the derivative of x is just 1. Since we're differentiating with respect to x, that doesn't create a differential piece. And then to take the derivative of e to the y, that's kind of like a chain rule. So the derivative of the outside is just e to the y, and the derivative of the inside is 1 times y prime. So just simplifying down, I have this piece. And then we'll just differentiate again. Now I may want to go back and end up solving for the derivative, but I'm just going to leave it the way it is for right this moment. Since it's asking me to evaluate this and not just find the equation for the second derivative, it wants a specific value. It's probably easier that I don't isolate the first derivative here and I just leave it the way it is. Since I would end up with like a quotient or something going on here, it might just be easier to leave it. Is my motivation there. So again, x times y to the first is a product rule. and then I have to take the derivative of y, and then taking the derivative of y prime times e to the y is another product rule. And the derivative of 0 is just 0. So the derivative of y prime is just y double prime. The derivative of x is just 1. The derivative of y is 1 times y prime. And the derivative of e to the y is e to the y times 1 times y prime. And the derivative of y prime is just y double prime. Bless you. So now I think here I'm going to go back and get the y prime by itself and find out what that value is and then plug that value in. So y prime is going to be negative y over x plus e to the y. And when I evaluate that, when x is equal to 0 and y is equal to 1, I get negative 1 over 0 plus e, or just negative 1 over e. So I'm going to have 0 times y prime plus negative 1 over e plus negative 1 over e plus negative 1 over e squared times e to the first plus e to the first times y double prime. So that just is 0. I add those up, and that's negative 2 e to the, or negative 2 over e. And this is going to be 1 over e squared times e to the first is just e to the first, which is just negative 1e. And then I have e y double prime. So if I add the 1 over e over, oops, those primes in the wrong spot. And then I divide both sides by e. I get y double prime is 1 over e squared. And I think that's our final answer. Is that what the back of the book had, Mia? Well, let's look real quick. Right? It felt like, it feels like a back of the book kind of answer for one of these guys. It's 1 over e squared? Okay. It's like I thought I did that right, but of course it's like pretty easy to goof up a negative sign or something in a problem like that, which I wouldn't put beyond my capabilities. Mia, does that? It's a tough one, right? That had a lot to it. Whenever you're looking for the second derivative for an implicit, like it's gonna get messy. Like it's not gonna feel, you know. And this was actually easier than having to like just find the equation for the second derivative, because we never actually had to plug in the expression negative y over x plus e to the y and try to simplify anything, which would have been kind of gross. And I think again, it's like 50-50 here as to whether what I did here by differentiating again, or separating and trying to differentiate that, which one was going to be the easier derivative to handle. Some of the product rules that happened when I did it my way were maybe kind of tricky to notice. There's a product rule going on there because you had like x times the derivative of y to recognize that you need to do a product rule on that. Maybe it's not super obvious. As opposed to the fraction where it's like, just looks like a quotient rule. There's nothing kind of goofy going on there. Going either direction would have been fine. This also has the added advantage of the y prime or y double prime already being separated when you do the derivative. If that matters, I don't know. But does that feel okay? Yeah. Again, and also I think again tricky was recognizing that like at the very beginning you had to figure out what the y was going to be that paired with that x to not make that. It's easy to not make that realization. Like, what do I plug in for y? You know, so that's also kind of tricky there. Mackenzie, number 1 on 3.5, number 1. Sure. Actually grab all of this because there's a bunch of directions that go with this. All right. It says find y prime by implicit differentiation. Okay. So if I do that, that's going to just, derivative of 9x squared is going to be 18x. And the derivative of y squared is going to be 2y times the derivative of y equals 0. So I'm just going to subtract 18x over and then divide by 2y. Or divide by negative 2y. So that's my answer for part A. For part B, it says solve the equation for y explicitly and then differentiate to get y prime in terms of x. Okay. So maybe I subtract 9x squared from both sides, and then divide both sides by negative 1, and then we'll square root both sides. So there's me getting the y by itself. And then if we take the derivative of both sides, the derivative of y is 1, and then I get the y prime piece. Can pull that plus or minus out. And I'm going to think about this as a chain rule problem. So the derivative of the outside is going to be 1/2. Oops, plus or minus. To the negative 1/2, and then the derivative of the inside is going to be (18x). So y prime equals plus or minus 18x over the square root of 9x squared minus 1. Oops, that should be 9x, right? Because the 1/2, I forgot it. There we go. And if you notice, if I take what y is equal to and I substitute it in here, what am I going to have? The exact same things, right? So those are equivalent, so I should feel pretty good about having done that correctly. Part C says, check the solutions for part A and B are consistent by substituting. Okay, so that's what we just did. So I subtracted 18x over and then divided by negative 2y. Are you talking about that?
No, I'm sorry.
18 times a half.
Oh, okay.
That's for the 9. Does that feel okay, Mackenzie? Mm-hmm. Now, of these two processes, which one feels easier? Kind of the first one, right? Like that seemed way less painful. Now, they gave us equivalent expressions. That's fine, depending on whether you accept a y in your answer or not. But like, not a big deal to have it in there. And certainly doing part A was way less algebra than part B was. And the chain rule involved in part B, I think, was more difficult than anything we had to do in part A. So, Victoria?
Could you do
Same section? Sure. Okay. Do that. Oh boy, that was not where that was supposed to go. All right, so 55 says find the derivative of the function and simplify where possible. Our directions. So notice that here we have the inverse trig function, so I'm going to have to be using that. Now, for the first one, when I take the derivative of cotangent inverse t, that's just the derivative rule, so I can just copy down that right away. But if I look at the second one, what do I have to do here? That's a chain rule. Yeah, very good. So if I do that, I'm going to have the same thing, but instead of x, I'm going to have, oh, I guess that should be a t here, huh? Instead of t, I'll have 1 over t. And then I'll have the derivative of 1 over t. Now it says to simplify where possible. At this point, the calculus is done, I want to point out to you. But the directions say to simplify if possible, or as much as possible. And Mr. Gulick has some suspicions that this is going to actually work out to be pretty nice. Wait a minute, Mr. Gulick. Wait a second here. What is this that's just happening? Is this doing what I think it's about to do? If so, that feels like pretty crummy of you to assign a problem like this. Did that just simplify down to 0? I think it did, folks. I think it did. Let me double check
How do
the.
you multiply the negative one?
Sure. So I multiplied the negative 1 into the numerator. So that's what changed it to a negative sign. And then I had to distribute the t squared into the denominator. So t squared times 1 is t squared. 1 over t squared times t squared is just 1. Yup. You're playing with fire there, Sophia, but
My odds are better that way.
Mackenzie. Same section, 59? Okay. Oops. Missed what I wanted there. This is a big dog here, huh? All right. So remember here, first things first, arc cosine is really kind of the same thing as cosine inverse, right? So if I use this, you should recognize this as a chain rule, and kind of a pretty nasty chain rule, right? So if I do the derivative of the outside, that's going to be 1 over the square root of 1 minus x, but in our case, the x is this big nasty fraction here. So that's the outer derivative. That's the derivative of cosine inverse. Now we have to do the derivative of the inside. So that's a product rule. So the denominator times the derivative of the numerator minus the numerator times the derivative of the denominator. Oops. All over the denominator squared. Yuckarooskies. All right, so let's see here. If we do that, I get negative a squared sine x minus ab sine x cosine x. And then I'll have minus b squared sine, but it's minus a minus, so plus. And then I'll have minus ab cosine x sine x, but it's minus minus, so it'll be plus. And that's nice because those guys will cancel out for me at least. And then I'm going to multiply this through but to do that, I have to think about it differently, right? What do I have to think about that as? Okay, so this part I need to think about as the square root of a plus b cosine squared times the square root of a plus b cosine squared. I wanted to think about it that way so I can distribute this thing through and it'll clear the fraction for me. So this is the same thing as the square root of a plus b cosine to the fourth, right? X squared is equal to the square root of x to the fourth, right? Or I could think about it as like the square root of x squared times the square root of x squared. That's what I've done there in blue below. I've just taken that thing and rewrote it that way so that I could multiply one of them through and clear the fraction out of there. Does that make any kind of algebraic sense? So now I'm down to this. Can I do much better than that? Well, let's write that in blue below. If I FOIL those guys out, get this minus that, and that's nice because that guy and that guy will cancel out. Yes. So I have these things squared, right? So I FOILed those out and then distributed through the negative on that second one. Is that okay? Is it too fast? Do you need a minute? If you need me to slow down or re-explain something, like, you can stop me. I want to point out to you the calculus is over a long time ago, right? We're just doing algebra now. And it's like nasty algebra, but it's like, it's good review algebra, right? It's like just unpeeling this thing, like it's a big onion.
What you did for 1 square, 1 minus, you can say cosine over a plus b cosine all squared. Did you substitute 1 for?
I didn't do any substitutions.
Okay. Where's that one? Like the b. You have.
What b are you talking about? No, I don't know at all what you're saying.
So
you started mumbling there.
The first
At the top of the left-hand corner, can you explain that? Like, why did you draw arrows to?
Because I was foiling,
Oh,
or
you foiled.
not foiling, distributing. Like I took that and distributed it
Okay,
into
gotcha.
there. So I distributed one through and left the other one because one of them was going to clear the fraction, but the other one didn't.
Okay, I got you. Just wanted to cancel it out.
Yeah. Sophia, what's up?
So does this square root sign still exist?
That square root? Yes.
Yes.
In the denominator, yes. That's still there. So what do we have left under there? We have a squared minus b squared. Let's actually do this, because that's probably going to make it a little easier. Okay. Now let's do it all under one first. So I have a squared minus a squared cosine squared. And then I have plus, or I should say, yeah, we'll do plus a negative b squared plus cosine b squared. It's all under there. And then this guy is still floating around here. And I'm going to just do that. So that's going to be the absolute value then. Just make my life a little bit symbolically simpler. I think it's probably a good idea to do that. And look at what I can do down here. Look at the clever factoring I can do. Well, it's about to get a little bit better.
Why do we do absolute
Well, if I take like the square root of something squared, like if I put -1 in there, it's like the same thing as an absolute value. Now, if you'd missed that, I don't know that anybody's going to like super complain about it, but technically that should be there. And what do you guys recognize here? Yeah, what identity is it? Oh, no.
I guess.
It's sine squared, which is great. Because all of that's still under the square root, right?
Oh.
So when I square root that sine squared, I can pull a sine x out. I know, guys.
I'm running on the margin.
I use that. And then, ooh, look at this. Right? I can do that. I just took a -1 out, right? And then this can cancel with that and just leave me a square root in the numerator.
Wait, how did you get this?
So if I have like x divided by the square root of x, that's the same thing as like the square root of x squared divided by the square root of x. So they just reduce down to be like the square root of x over 1. right? So that's all I did here with this thing and that thing, right? Because they're the exact same thing, just one is under a square root and one isn't. So I can reduce it the same kind of way. Not obvious to see that, but look at how nice that eventually got. I think that's about as good as you can do. Well, again, we've talked about this when it comes to test time. What is Mr. Kulik going to do? I'm either going to say you're done when the calculus is finished, or the problem is going to say show this derivative is equal to this, so you know where to get to, right?
So will this be on the test if there's a problem like this?
That took Mr. Kulik 10 minutes to walk through. What do you guys think? Is that a reasonable thing for me to put on a test?
Well, it's the only question.
I think it might be
Plus. How long did you spend on this doing calculus?
like 2
Like 10% of the problem was the calculus part.
Tell me where the calculus stops.
Sure. It was right here. The calculus was over at that point.
So
Everything after that was algebra that we did.
okay, go back to
Well, again, you know what the saying goes is nobody really learns algebra until they take calculus.
well, I get it now.
Okay? Of course. Oh boy, look at this. I just want to say one quick thing. Quick thing here. Can I say one quick little thing here? All right. So this probably should have been the absolute value of sine. So I can't reduce that immediately. But look at the problem. It says that x is in the first two quadrants. And what do we know about sine in the first two quadrants? Positive. So we can drop the absolute value along the sine and reduce it. So there's that. Okay. That was a lot. I know. Now everybody, I think, was starting to feel better, and then we did this, and now everybody feels worse.
On the test, I'm guessing it should be a score problem.
73? Sure. And this one, again, it was the algebra parts that were bad, and don't be like, I feel like I'm bad at math now because I feel like I can't do algebra. This is the algebra part isn't supposed to be easy. Like, the algebra part can be more complicated than the calculus part very quickly. That's why it's AP, though. No. I did hear that they're supposed to be starting an AP pre-calculus course, though.
Oh, are you kidding?
That's interesting.
Let's see. What's the highest level of
Theoretical.
I mean, like
class-wise?
I mean, in high school or period?
Like in high school.
Algebra 2?
And then like in general.
I mean, you can keep taking algebra courses for a long time. I mean, I've taken abstract algebra, I've taken like modern algebra 1 and 2, I've taken linear algebra, I've taken like algebraic number theory, like a bunch of courses.
I have a friend who's taking abstract algebra and he's a senior right now.
Yeah.
So it's like calculus like BC or 3 when he was in junior or whatever.
Yeah. That sounds about right. Okay. So it says the equation, yada, 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 represents a rotated ellipse. That is an ellipse whose axes are not parallel to the coordinate axis. So normally when you have an ellipse, you're going to have something like this, where like the axes of the ellipse, you know, like this midline and this midline are like parallel to the coordinate plane. What we're talking about here is going to be something like this. Everybody's okay with at least the verbiage of what it is they're talking about? I'll graph this in a second so you can actually look at it. It says find the points at which the ellipse crosses the x-axis. So what is that going to be? That's finding the x's when y is 0, right? So there's 2 points. There's negative square root of 3 comma 0, and then there's positive square root of 3 comma 0. Then it says show that the tangent lines at these points are parallel. So we need to show then that y prime of square root 3, how do I want to write that? That's what I'll write it.
What is WTF?
Want to show. So what we want to show then is the first derivative when evaluated when x is negative square root of 3 and y is 0 is equal to the first derivative when x is square root of 3 and positive square root of 3 and y is 0. Does that feel okay? So let's go ahead and find that first derivative then. So there's my equation. So there's that. So derivative of 2x or x squared is 2x. The derivative of, should be a minus sign there. Derivative of xy, I have to use the product rule on, so that's x times the derivative of y, and then distributing my negative through, I get y times the derivative of x, and then I have the derivative of y squared, which is 2y times dy dx. Okay, now all you need to do is plug these in. So if I plug in negative square root 3 for x, and solve, I get that y prime is going to be 2 root 3 divided by root 3, which is 2. And if I plug in the same thing except positive root 3, I get that y prime is going to be negative 2 root 3 divided by negative root 3, which is 2. So since the slope at the point -3, 0 is equal to the slope at the point +3, 0. Those tangent line, the tangent line through -√3, 0 is parallel to the tangent line through +√3, 0. And we're done. Victoria, was that?
Yeah.
Wasn't as bad as you thought. The problem sounded much worse than it was. The calculus is actually pretty easy. The algebra is actually pretty easy. Although it sounded pretty scary at first because you're talking about a rotated ellipse and you might be thinking, oh, lordy, what is this going to look like? But it was actually not so bad. I think this is on par with something that I would feel comfortable asking you in a test setting.
Could you go up to the sort of Alright, so that was the calculus.
No, the first part was really just,
Reading the story from.
well, it was finding some piece that we needed. But we didn't do any calculus in the first step. In the yellow, that was all algebra.
Oh, I see. Because you're just finding that you
Yeah.
using kind of common sense that y equals 0. Okay, I got you. Y equals 0 because.
It says it's crossing the x-axis.
Oh, which means it always has to be 0 because. Okay. Gotcha. Okay.
Okay. How are we? How are we?
Could be it's the review of the problem.
Sure. So let's talk about the test and the test format and all that since we're kind of on there. My kind of feeling is at this point, maybe we do the test after 3, which is up to 3.5, and we'll leave the 3.6 onto the next piece. Is that okay with you guys? It feels like everybody feels adequately overwhelmed with what we've done to this point. So maybe it's wise for Mr. Kulik to just stop here. Nico?
Can I use logarithmic differentiation on it then or no?
Sure. Sure. Why not? I guess I would ask this also then, is that I want to be able to do, this.
Yeah.
Can we have that? Can you give me that derivative rule also to put on the test? If I'm not doing any content really from 3.6 other than this derivative rule.
Okay. So we need to know that. Yeah.
Well, I just want to be able to like put it in a problem. Like if I have y equals like cosine x times the log of x, I want to be able to just have it as a derivative rule you might need to use in a bigger problem.
So it would be like negative sin x.
Nope, that's a product rule,
Oh, yes, correct.
right?
We haven't changed it. No, not changed it.
There's no chain in this, but
Like, I don't know if there's added.
It would be.
so it'd be like cosine x times 1 over x plus log of x times negative sine x,
Okay, that's
Yeah,
right?
makes sense.
That's all I want to be able to do is just have another derivative rule that I can mix in with my
Right.
with my product quotient chain stuff, which is going to be the most majority of the test, right? Okay, so I'll leave 3.6 off. We'll come back and we'll finish 3.6 later. We had kind of started talking about it, but it feels like everybody's pretty ready just to do to worry about what we've covered to this point. Yeah, it's probably for the best. And looking more at those later sections, I'm not sure I really want to do all of, like, I think it was 3.8 or 3.9 I was looking at. I'm not sure I really want to do it. I don't think I really need to. So let's see here. So I have this already done now, and we can just kind of cross off the 3.6. Nope, that's the wrong one. That wasn't what I wanted. My apologies. There we go. Grab the wrong one. So the test format, and I reserve the right to still be in the editing process to make it shorter than what I've quoted here. That feels out, nobody's going to object to that if it's like, hey, that was less questions than you actually said. Okay, so I just I'm just being clear, right? That I haven't printed anything, that I'm still kind of proofreading and like going over and being like, is this too much? Is this too much? Because I don't want to have a repeat of what happened last time, right? So I'm trying to be mindful of that. So this is the way I've tried to format it. I have 3 questions where I ask you to find the derivative, and all those problems could be done with no product, chain, or quotient rules, although you could use them on them, but there'd be algebraic ways to work around it. Everybody's okay with that?
So that's just like chapter.
No, it'd be like, like I might have something like x squared times the square root of x, right? You could do the product rule on that, or you could just think about it as like x to the 2.5, and then just use the power property on it, or the power rule on it. So that's what I mean by like problems that you don't need to use those on. You can just use like a derivative rule without using one of the special ones. Is that okay? I have 3 problems where I ask you to find the derivative where you only need to use one of the product, chain, or quotient rule. So again, you might be tempted to use more than one, and some of them you could use more than one to do it, but you don't need to. Every one of those problems could be done with just one of those 3. Everybody's okay with that? I have 2 questions then where I ask you to find the derivative, and you need to use 2 of product, chain, quotient. And then 1 question where I ask you where it has at least 3 product, chain, quotient. Now when I say at least, or I say 2 or at least 3, it means like 2 could be 2 products, right? 3 could be like 3 product rules.
Like three things multiplied by each other, so you do 3 products.
Well, 4 things to get 3 product rules,
Okay.
but yes. Yeah, that's what I mean. So it doesn't necessarily mean like, oh, at least 3 of these means I'm going to have a chain, product, and quotient all in the same problem. It might be that, or it could be like 2 products and a chain, or it could be like 3 chains, or it could be, like,
Okay.
like it just means that there's going to be 3, you have to use at least 3 of the rules. And then I have 1 question where I ask you to find a first derivative using implicit differentiation and using that derivative to write the equation for a tangent line and normal line. And then one question where I ask you to find the second derivative implicitly at both a point and then in general.
It's implicit where it's like dy over dx.
The implicit is where you have x's and y's
Okay.
that are maybe unseparable.
So that's 3.5.
So 3.5, yes. And then I have some review questions that I picked out that I thought would be good similar things to what I was looking at when I looked at the test questions. So these are all problems you have done. And then I have some extra, like, here's some nasty derivatives. Like these would be one of the the hard ones on the test that have at least like 3 things going on.
Okay.
Right, if you look at the first one, what do we see there? I see 3 chains of product and a quotient.
3 chains.
Yeah, each of the 3 expressions that need a chain rule with it. The second one, I see, what do I see? I see a product, I see a chain, I see a quotient, or 2 quotients. Or sorry, 2 chains, a product, and 2 quotients. The last one I see, what do we see there? I see 3 chains and a quotient and a product.
Where are the 3 chains for number 1?
Well, sine 3x squared, when you differentiate that, you need a chain rule.
Oh, yeah, because...
The square root of x cubed minus x needs a chain rule.
Yeah,
And then e to the 3x minus 1 needs a chain rule.
okay, I see.
So like those are nasty boys. Those would be, like the ones that I give you on the test would be certainly no more difficult than one of these guys, which are rough stuff, but like eminently doable. And again, on the test, the format will either be like stop when the calculus is done. You don't need to simplify. Or it'll say like show that the derivative of this is equal to this, where it's like I'm telling you what the answer is. You need to provide the working to get there. Which again, like that feels like the fairest way to kind of format those. If I'm looking for simplified to a certain point, I'm going to tell you what that is and frame it as a like show question rather than like find the derivative.
So out of the quotient, chain, and power rules, which one should you do first? Like, how do you know which one to do first?
So it's really implied by the order of operations in the problem. So if I look at that first problem,
You do the
quotient first.
If you do the product, inside the product, you do 2 chains.
Yes.
And the bottom, it would be another quotient. Or I mean, the bottom, it would be another chain.
I'm starting here, right?
Right.
When I have to differentiate this is a quotient first,
Yeah.
right? So when I take the derivative of, or the bottom times the derivative of the top, when I take the derivative of the top, then I need a product.
Oh, because, yeah, those are...
And then it's going to be minus the top times the derivative of the bottom. When I get to the derivative of just the bottom, I need to do a chain.
Okay.
And then when I come back and start working the product, when I do the first one times the derivative of the second one, chain on that one, plus the second one times the derivative of the first one, chain on that. So it's just kind of when you get to it.
I see what you mean.
It's not like it's always going to be the same order. And in general, like I can write a problem that uses all 3 of them, and it could be in any of the 6 ways orders that you might could order them. I could write a problem where it's like, oh, this one needs to be chain product quotient. This one needs to be quotient product chain, and this one needs to be product chain. Like some different. And I can write a problem so it's in any order I want it to be. Mia?
Just a little bit.
Yeah, and I'll give you the answers to these too.
So, where it says find the first derivative implicit, so would we just like find do this differentiation and then it'll give us
And yeah, and I'll say like, okay, then find the tangent line at this point.
Okay. And then
Or when x is equal to this value, and then you have to find the y and use it. But it's
okay. And then for the second derivative one, is that like the one we did did, there was like 39.
Yeah, that would be very similar to 39, except I would ask the additional step of like going back and plugging it through, right? When we were here, we never went back and like got the second derivative in terms of x and y. We just went straight to plugging in the numbers. So that second part where it's like, and then find the general form. And that screams of a show question, right? Because the algebra there could get a little hairy. Victoria.
So when we come back on Tuesday, is that going to be the test day, or are we like asking questions that day and then take the test Thursday?
Which would you prefer?
Thursday.
Let's do that then. Okay.
So nice. I'm like gonna buy like a coffee or like a donut.
I mean, thank you, but like you don't need to do that. Like I want you to do well, right? Like I sincerely want you to do well. Thanks would be just like being well prepared and like doing your best, and that's all I can ask for.
Doing your homework, yes. Doing your homework, not sending us one email.
And then the other thing that I have for you guys, so
You'd be like 1 o'clock.
Anytime there's not maybe there's such a constant or is it like if you live in the state of Michigan, is it an unwritten requirement to apply this way?
and if you think so I also went and wrote a kind of a more standard looking review for you guys also. I'll put an answer key for this up also, maybe not today, but soon. And then you can ignore problem 13 where it's the log differentiation problem. But this is like another, like way I would ask you to do something, where if I want it simplified to a point, it's like, okay, show this. And that was a nightmare, by the way, simplifying it to there, but it was fun. It was a fun nightmare.
What do you think we should? Do you think when we just study that would be fine, or should we still do the one book?
Yeah, I mean, here. I mean, let's be super honest, right? Like, you should work through as much of it as you can. Like the homework quizzes were fine, but they weren't great. Like I graded them in such a way that like if you did 3 questions correct, I gave a 10.
Okay.
4. Like if you did 1 of them correct, I think I gave you an 8 or something.
Oh, so I only got 2 right. That's kind of...
If you got 2 right, I think I gave you a 9. If you did something,
See, I thought I did good. Like, I kind of...
yeah, right. So like again, do some practice. Do the practice. I can't remember if I mentioned this to you guys. But I made on the links. I did a Quizlet for you guys, so you can just like crank through these rules, right? Like I think I typed them all in there for you. So this is just derivative rules. So I didn't have any theory or any formulas or anything in here, but like you have got to know, for example, something crummy like, like cosine inverse is this. Like you have to have them memorized.
I did not know that one.
Like.
No, this is great information.
So I did that for you also.
I thought that would have been one negative sign, but
So like, please spend some time with memorizing the derivative rules. You need to know them.
that's not good.
Wire concert got canceled. It's not so sad.
Yeah. Why did they cancel it?
Just because he's sick.
Oh.
The linear motion. When do you think that there's some right time to start listening to music?
To what?
Start listening to music.
I mean,
After Thanksgiving.
I don't know. I did December 26th.
Yeah, it's not very good.
No, did you get it?
I know, that's what I'm saying, bro. I was like,
Oh, wait, yours is good. Because you want to wait, like, listen to it all year.
Sure, whatever you want. That's what you want to do. Like, go ahead.
No questions when you stop. You're celebrating for everybody.
Maybe you just like Christmas songs. If you feel like it, if it makes you feel good, just listen to it.
Like if it makes you go on our couch.
What, yeah, I think it's a player.